Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Higher Tier Component 2 paper from summer 2022. This paper is worth 120 marks in total, and this is the third video of 6. It will focus on questions 9 to 13, which account for 20 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only ways some mathematical skills can be applied. Okay, let's get started. Question 9. Bronnie takes part in a triathlon. In this race, she swims 1.5 kilometres in 3/4 of an hour. She cycles at an average speed of 27 kilometres per hour for 1 hour 30 minutes, and she runs 9 kilometres in 1 hour. The average speed of the winner is 16.1 kilometres per hour. Show that Bronnie does not win the race. So there are 3 parts to a triathlon: swim, cycle and run, but the average speed here is the speed overall, so this is the total speed for the whole thing, okay? So we need to figure out the total distance and the total time for the triathlon, and then we can work out Bronnie's total speed overall, okay? So we want total distance, we want total time. Okay, so let's look at the information that we have. I'm going to sort things into a little diagram here. So we have swim, cycle and run. And I'm going to put speed, distance and time there. I'm going to sort it into a little bit of a table. And I'm going to put the information the question gives me in. And this is my totals column. Okay, and remember, to work out the total speed, this is what I'm aiming for, I need to know the total distance and the total time. So for swim, the distance is 1.5 kilometres and it takes 3/4 of an hour. So 3/4 of an hour is 0.75, so that takes 0.75. Cycle, so they cycle at an average speed of 27 kilometres per hour for 1 hour and 30 minutes, so that's 1.5 hours. And then runs 9 kilometres, so the distance is 9 kilometres in 1 hour. So what we have here, guys, we can find our total time because we can add these up. So 0.75 plus 1.5 plus 1. So the total time is 3.25 hours. But what we don't have is this distance here for the cycle part of the triathlon to get our total distance. So we're going to calculate distance. Remember your speed, distance, time triangle. Distance is speed multiplied by time. So the distance cycled is the speed, 27, multiplied by the time, 1.5. So that's 40.5 kilometres. So 40.5 kilometres. Now we have the distance for each separate part of the triathlon. We can get the total distance. So 1.5 plus 40.5 plus 9 gives us a total distance of 51 kilometres. Now we can work out the total speed. Speed's different. We can't add the 3 speeds up. We need the total distance and the total time to be able to do that. So our total distance is 51, total time is 3.25. To calculate speed then, so speed is equal to distance divided by time. The distance is 51, the time is 3.25. So 51 divided by 3.25 is 15.69 kilometres per hour. The winner, the average speed of the winner is 16.1. Bronnie had an average speed of 15.69, so Bronnie does not win. So we've shown through calculations that she does not win. Question 10. So we've got a diagram here with lots of points marked. And the question tells us David is trying archery for the first time. He stands at point A and tries to shoot an arrow at the target T. So point A and target T. But he misses. His arrow lands at a point X such that X is equidistant from S and R. So this, where his arrow lands, is equal distance between those 2 points, S and R. And XY is perpendicular to the path. Okay, so this is the path, and the line from the from where the arrow lands in X is perpendicular to Y. So the line that joins it would make it perpendicular to this path here. It says to construct accurately the position of X and measure by how many degrees David's shot is inaccurate. You must use a ruler and a pair of compasses to construct suitable arcs and lines. So you need ruler, compass, and we are going to need a protractor to measure our angle at the end. So we're going to construct, give myself some space, we're going to construct here to meet this criteria. So the first thing is the arrow lands at X, which is equidistant from S and R. So equal distance from 2 points. This is a perpendicular bisector, guys. So you're going to set your compass on one of those points, make sure it goes over halfway, and then you're going to draw yourself an arc. And then do the same, keeping your compass exactly set as it is from the other point that it's equidistant from. And then using a pencil, you're going to, where the 2 arcs intersect, you're going to draw a line through. And you want your line to go across the whole of the diagram. So that line through there. So all points on this line are equidistant from S and R. So that perpendicular bisector gives us everywhere that's equal distance. So the X, where the arrow lands, is somewhere on this line. Also, from where the arrow lands to Y, that line that would be formed, XY, is perpendicular to the path. Okay, so we're perpendicular to the point Y. So we're going to do a perpendicular bisector again, but this time it's slightly different. We're going to use point Y, and we're going to make sure our compass is set, not too small because it gets tricky, but not over the end of the path. So we've got it on Y, and I'm going to make an arc here, and I'm going to make an arc there. Okay, then I'm going to put my compass on where that arc has intersect my line. I'm going to extend my compass a little, because what I want to now do is a perpendicular bisector of those 2 points that I've just made on that line. So what you will see here is you've got an intersecting point here and an intersecting point here, and then when we join those up, it should go through point Y, and that's our perpendicular line. Okay, leave all of these construction lines in, because if you rub them out, you're going to lose marks. They need to see that you've done it this way. So now where is X? Okay, so X, where the arrow lands, is equal distance from S and R. So it's on this line, and it's also perpendicular to the path. So it's on this line. So it's where the 2 lines intersect. Okay, so that's the point X. Now what they want us to do is mark the position of X, which we've done, and then measure by how many degrees his shot is inaccurate. Okay, so we need to measure the angle from A to where the arrow landed, and we'll see how far off he is. So I'm just going to draw that as my north line, and then I'm going to connect A and X with a line also, and it's this angle here that we're measuring, guys. Okay, so remember, when we're measuring angles, the center of our protractor here goes on the point at which the angle is formed. our 0 line goes flush with the line that we're measuring the angle from. So centre, 0 line flush, and then we're reading around our angle to this point here. So I'm reading that as 34 degrees. So that angle is 34 degrees. So David's shot is inaccurate by 34 degrees. Question 11. So we've got a coordinate grid. We've got two shapes on the coordinate grid here. Part A, describe the single transformation that maps triangle ABC to triangle PQR. So ABC to PQR. Okay, so we can see that this quite clearly is an enlargement because ABC is a starting triangle and then PQR has been made smaller. So we're going to say it's an enlargement because that's the transformation that changes size. Now we need to figure out our scale factor and we need to figure out our centre of enlargement, and for that we'll give them a coordinate. Okay, so scale factor to start off with. So let's have a little bit of a look. So we're going to compare points excuse me, on these triangles. So we're going to compare the journey from C to B to the journey from R to Q because they correspond with each other. So to get from C to B, we have gone down 2 and then across 1, 2, 3, 4, 5, 6. So down 2 and then we've gone across 6. Let's see what the journey is from R to Q. So to get from R to Q, we've gone down 1 and then across 3. Okay, so the distance is halved in each case. So our scale factor is a half. Now we need to find our centre of enlargement. So to find our centre of enlargement, we're going to draw ray lines because that makes life a little bit easier. So when we're drawing ray lines, we're going to join the lines together for corresponding parts. Okay, so these two corners correspond. So we're going to draw a line through those two. A and P correspond. So we're going to draw a line through those two. And then B and Q correspond. So we're going to draw a line through those two. And you can see that all three ray lines intersect at this point here. So that's our coordinate. That's our centre of enlargement. So it's along to 4 on the X and then along to 5 on the Y. So our centre of enlargement is 4, 5. Part B. On the grid above, draw the enlargement of triangle ABC, scale factor -1, centre 0, 3. Okay, so we are going to work with triangle ABC using a scale factor of -1 and the centre of enlargement as 0, 3. So 0, 3, that's our centre of enlargement there, guys, okay? So we're going to enlarge this shape, ABC, by a scale factor of -1. So when we're dealing with negative scale factors, the journey reverses and the journey time multiplies by whatever that value is. So let's have a look. Point C from our centre of enlargement is 1, 2. To the right. So to reverse that, because it's a negative scale factor, it's going to go to the left, but it's a negative scale factor of 1, so it's going to be 1 times itself, so it's going to be exactly the same journey but in the opposite direction. So C would move to here, and then B is 1, 2, 3, 4, 5, wait, from the centre of enlargement, ignore me. 1, 2 down, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this time we're going to go 2 up and 8 to the left. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so then the last point is A. So we're going to go from our centre of enlargement and we're going to go 1, 2, 3, 4 to the right. 1, 2, 3, 4, 5, 6 up. So that means we're going to go 4 to the left, 1, 2, 3, 4, and 6 down, 1, 2, 3, 4, 5, 6. So that's the new corners of our enlarged by a scale factor of 1 triangle. There you go. Question 12a. Find the next term of the following sequence. So the sequence is 0, 7, 26, 63 and 124. So we're going to start by seeing what happens to get from one term to the next. Let's see if that helps us. So to get from 0 to 7, that's a difference of 7. 7 to 26 is a difference of 19. 63 to 26 to 63 is a difference of 37. And then 63 to 124 is a difference of 61. Okay, not very helpful. Let's spot the difference of the differences, guys. So 19 subtract 7, that's 12. 37 subtract 19, that's 18. 61 subtract 37, that's 24. Okay, still not helpful, but actually, if you look, each of these now have a difference of 6. So that gives us something to work for. So remember, we're aiming for the next term, so we need to find the next in each of these differences. Okay, so if we were to do 6 here, 24 plus 6 would be 30. 61 plus 30 would be 91. So 124 plus 91 would be 215. So 215 is our next term. Part B, find the nth term of the following sequence. So our sequence is 3, 9, 19, 33 and 51. So let's start by finding that first difference. So 9 take away 3, well that's a distant difference of 6. 19 take away 9. Oh my goodness. 19 take away 9 is 10. 33 take away 19, that's a difference of 14. And that's a difference of 18. So our first difference isn't helpful. We're going to find our second difference. So from 6 to 10 is 4, 10 to 14 is 4, and 14 to 18 is 4. So our second difference is equal. So this tells us that we're working with a quadratic sequence. Okay, and our sequence is going to start 2n squared because our n squared coefficient is half of that second difference. So what I'm going to do to start off with is I'm going to generate that 2n squared sequence. I'll just draw myself a little bit of a table. So first, second, third, fourth and fifth term, because we've got 5 terms to compare it to. So 2n squared when n is 1. Well, let's do this in our calculator. Let's make our life a little bit easier, guys. So if we're doing 2n squared, it's 2 times 1 squared. Oops. 2 times 1 squared. So that is 2. And then I'm going to go back and I'm going to do when n is 2. And then I'm going to go back when n is 3. When n is 4. So that's our fourth term. And then when n is 5 for our fifth term. So that's what the sequence 2n squared would look like. So I'm going to pop the sequence that we're aiming for underneath. And we're going to spot what's happening. Okay, so what do we need to do to get from 2n squared to our sequence that we're interested in? So to get from 2 to 3, we add 1. 8 to 9, we add 1. 18 to 19, we add 1. 32 to 33, we add 1. 50 to 51, we add 1. So our quadratic sequence is 2n squared plus 1. Question 13. A cuboid of copper has a mass of 2,150.4 grams and a volume of 240 centimetres cubed. A sphere of copper has a radius of x centimetres. Show that the mass in grams of the sphere is less than 38x cubed. Okay, so we've got mass and volume. We're going to work with density because we're working with a material here, copper. And the one thing that the cuboid and sphere will have in common is the density of copper. So we're working with density, mass and volume, guys. So let's find, we have the mass and the volume of the copper. Let's find the density. Because once we have the density of the copper, we have something else to work with, guys, okay? So density is mass divided by volume. So the density is 2150.4 divided by 240. Which is 8.96 grams per centimetre cubed. So this is the density of the copper, okay? So we have a sphere, and when we're working with this sphere, we're working with volume, density, and mass, okay? Density, we know. The density of the copper is 8.96 grams per centimetre cubed. The mass we don't know because we're wanting to show that it's less than that value. So the mass is what we're looking for. So we need the volume of a sphere. So the formula for the volume of a sphere is 4/3 pi r cubed. Okay, so let's find the volume of the sphere. So let's change that to volume. So we are 4 pi times the sphere has a radius of x centimetres, so that's x cubed. So let's pop this into our calculator. Not the x cubed part, just the 4/3 multiplied by pi. So that equals 4/3 pi x cubed. So that's the volume of the sphere. So 4/3 pi x cubed. Okay. So to find the mass, which is what we're interested in, we do density multiplied by volume. So let's do that. So our volume is 4/3 pi x cubed. Let's multiply it by 8.96. Which is 89675 pi x cubed. I'm going to leave it like that in exact form rather than write out loads of decimals. Though actually, we're trying to show that the mass in grams of the sphere is less than 38x cubed. Well, I've got the x cubed, so I do actually want this to be a decimal. So this is 37.53156.023 x cubed. So this is the mass here, guys, of our sphere. Show that the mass in grams of the sphere is less than 38x cubed. Well, 37.5x cubed is definitely less than 38x cubed. So we've showed that there.